Evening class, welcome to our presentation on validation and regular expressions. Before I proceed with the actual content, just a little update. As far as our schedule is concerned, we've now caught up the backlog and we are now proceeding in accordance with the study plan that's been published in your tutorial letters. So everything from now on will be happening at 2 weekly intervals. Our next class will be in 2 weeks' time. Your exercise 6 open on Monday, and you'll have 2 weeks to complete that. And then the next one will open in 2 weeks' time. Then you also have 2 weeks to study each section of the study material. You can, of course, move ahead at your own pace if you want to, but don't fall behind the published schedule. Then talking about the exercises, please make an effort to get up to date. The exercises will be getting more complicated and longer as we proceed, and you don't want to fall behind. Exercises 4 and 5 I'll upload after the closing date for the assignment because there's too much code in there that could be used for the assignment. Then exercise 6, if you read through that, you'll see there's a class address validator that you need to upload from resources on my Unisa. For that class, all you have to do is integrate it into your application. Then there's 2 regular expressions you have to set using the setters and then connect some signals and slots. You don't need to do anything with the actual code of that class, but I do suggest that you look at it and to get an idea of what's involved in coding your own validation. It can get quite complicated. So it would be a good idea to have a look at that code and make sure you can follow the process. And of course, if you want to improve the solution, feel free to do so. But it's worth looking at. It will give you some insight in what's required to do your own validators. Do we have any questions so far? No. Okay, then let's get on with it. Right, regular expressions and validation. This is what you are required to know. You have to be able to use input masks to control user input. You must know the purpose of validators and how QT supports validators. You must know how to set validators for input widgets in QT. That's an important aspect of it. You must be able to use validators. And then you must know the purpose of regular expressions and have an overview of regular expression syntax. In fact, overview is probably a bit of an understatement. You need to have a good understanding of regular expression syntax. You must know how to implement regular expressions. Then you must understand the relationship between validators and regular expressions. Validators generally use regular expressions a lot, so the two go together. And then you must be able to write simple regular expressions for validation of input in QT. And if you do exercise 6, you will get some practice at that. Okay, I see there's a query about increasing the volume of my mic. I don't think there's any way I can increase the volume. You have to increase your own volume, I think. But I don't know of any way to increase the microphone volume. Okay, there's others who say that I have a problem, so I think it's your own settings you must have a look at if you're having sound issue. Okay, so that's what we need to know for regular expressions. For those of you who are familiar with regular expressions, you should probably have come across in some of the modules you've done already, so this will be quite easy for you. Those who don't know anything about regular expressions, they can be a bit tricky at first, but they're not too bad once you understand how they work. So let's move on. Okay, validation in general. Okay, this is generally just background. As you know by now, your exam, you're not really going to get questions on theory. It's all about application of knowledge, but you do have to have a bit of understanding of what it's all about. But this part, there won't be anything detailed about it. So the process of validation is the checking or proving validity or accuracy of input. So that's all it is. Validation is just checking that you have valid, accurate input. We've previously spoken about the anti-pattern of the input kludge, and that involves allowing input into an application without validating it. So you must know about this input kludge. That kind of question comes up quite often, and you must be able to, if you're given a sample of code or something, excuse me, you must be able to recognize an input kludge and be able to recognize and see that there's no input validation. Just remember, question may not specifically say that you must look for an anti-pattern or for an input kludge or something, and you might just get some code where there's no validation. You must be able to recognize that as being an anti-pattern and how to fix it. And the obvious fix, of course, is to implement validation. Right, the numeric input often needs to be within a given range. So using validation, you can set a range and only allow input, numeric input within a given range. And one very big problem is division by 0. Please be very careful that you don't allow inputs of 0 where you have division in your application. That's a very common error, this division by 0. Just make sure you prevent that by having input validation. Then string input often needs to be in a specific format. For example, a phone number, an email address, ID number, and so on. And you need to then validate that that input is in fact in the correct format. Okay, validation can be done using input masks and or validators and regular expressions. So we'll be looking at input masks and then using validators and regular expressions. But remember, validators and regular expressions generally go together. Okay, QT has some predefined input widgets or dialogues that restrict input to valid values. Some of the most common ones, and these aren't the only ones, there are others. QDate edit, it validates the date and a range of dates and also the date format. You can set all of that within a QDate edit. A QTime edit validates time, also a range of times and a time format. The QSpinbox validates integers. You can also set a range of integers. And QSpinbox, you can also set it so it does month names, for example. You don't have to do anything specific for month names. It's just a setting on a Spinbox which will then allow you to validate month names. QDoubleSpinbox validates double, obviously, and you can set a range of doubles. Then the other thing you can do with this double Spinbox is you can set the number of decimal points. There's a set decimals method, which you can use if you want to set a specific number of decimal points. Then there's a QCalendar widget, which validates and selects valid dates. For example, something like dates of the 31st of February are quite difficult to control. It's obviously an invalid date. And just trying to do that by validating your inputs, you can validate days from 1 to 31, and you can validate months from 1 to 12. But it's very difficult to validate the two together. So it's quite easy to end up with a situation where you have an application that allows dates like the 31st of February. But using things like the QCalendar widget and the QDate edit prevents that and only allows users to select dates that are actually valid. And then note this one with QDate edit. It's actually generally a better widget to use than the QCalendar widget, because with the QDate edit, you can set calendar pop-up true. Then that displays a selectable calendar. It's in fact similar to the calendar that the QCalendar widget displays, but it doesn't take up half of your screen space. It's just a single line initially. And if a user clicks on it, the full calendar pops up. So it's just generally a better solution than the calendar widget, but obviously you can use whichever one's appropriate to your application. So that's just a brief look at what some of the predefined validation widgets are in QT. So there are others, but these are the ones that you would probably need to use most often. Then looking at input masks. And just a general note here, have a look at this example in your prescribed book, example 14.1. It's quite a useful one for using input masks. And you must also look through tutorial letter 105. There are quite a few of the examples from the prescribed book mentioned there specifically, and there is some updated code available in additional resources. So please look at those examples. And then also, as I said before, you must do exercise 6 as well. That will all give you practice in using input masks and setting validators. So what is an input mask? An input mask is an active pattern that controls what can be entered into an input widget. Note that it's an active pattern. It doesn't just sit there passively. It actually, if you like, reacts to input. So it's active. It allows valid inputs and it blocks invalid inputs. So it's an active pattern. An input mask prevents incorrect or invalid data entry. And the way it works is it emits a signal when the input is valid. So when you need input masks, you generally need to connect your signals and slots and then process the input once the valid signal is emitted. And QLine edit has a QString property, which is called input mask. And its accesses are set input mask, where you can set a QString as an input mask. And it also has a getter input mask, which returns what the current input mask is. So they're very easy to use. To set an input mask on a QLine edit, you just call the set input mask method with your string input mask as an argument. Okay, then looking at the meta characters for input masks, you do need to know what these are and understand what they do. As I said before, the best way to do it is to actually write some code and practice and see what's acceptable and what isn't. As I said, that example in your prescribed book 14.1 is quite a useful one to do. And there is also a small example in exercise 6. Okay, so what do you use for input masks? A capital A means that an alphabetical character is required, which can be capital A to Z or lowercase a to Z. If you use a lowercase a, it means that an alphabetic character is permitted, but it's not required, so it's optional. So you must know the difference for all of these, the difference between the capital letter and the lowercase letters. Capital N then is an alphanumeric character, required. I emphasize the required. It can be any alphabetic character, up or lowercase, plus the digits 0 to 9. Then a lowercase n, the same content, but it's permitted but not required. Then a capital X is any non-blank character required, so there has to be some kind of input. The lowercase x means that any non-blank character is permitted, but it's not required, it's optional. Then the digit 9 means a number or a digit 0 to 9 is required, whereas a 0 means that it's permitted but not required. So you must understand the difference between the two, where the input is compulsory and where it's optional. And a capital D means a number larger than 0 is required. In other words, the digits 1 to 9. And the lowercase d again means that your digits 1 to 9 are permitted but not required. And your backslash escapes special characters, and I'll show an example at the bottom, or it can be used as a separator. Where you want to escape your characters is if you want to use any of these meta characters as a literal in your input mask, then you have to escape it. Otherwise, it'll be interpreted as a meta character. Okay, then the hash means that a number or your plus minus signs are permitted but not required. And the greater than means that all following alphabetic characters must be uppercase, whereas the less than sign means that all following alphabetic characters must be lowercase. The exclamation mark turns off the case conversion. In other words, if you use the greater than sign to set capital letters, say you just want the first character capital, you would follow it then with the exclamation mark after that character to turn off the compulsory capital letters. So the greater than and the less than sign turn on your case sensitivity, and exclamation mark turns it off. Then any other character that's not mentioned above here, like a colon or minus sign, just wondering if it shouldn't be like it, and a forward slash are immutable separators. In other words, they're fixed, they're literals, and they're just used as separators between other characters. They don't have any special meaning. In some examples of setting input masks, notice that it's a string, so it's got to be in inverted commas. The capital D at the beginning here means that it must be a number larger than 0, and it's compulsory. In other words, what we're setting there is that the first number cannot be 0. We then have the nines, which means the number 0 to 9 is required. And then there's 2 literal hyphens in there, just use as separators. So this input mask sets a non-zero digit for the first character, then some compulsory digits between 0 and 9, and then there's 2 literal separators in amongst there. Then another example, 3 capital A's means an alphabetic character is required, which can be uppercase or lowercase. And then the 2 lowercase a's means that they're permitted but not required. So what that effectively means is an alphabetic character input between 3 and 5 characters. So just remember that the capital A and lowercase a, that doesn't imply the case. It doesn't mean that there must be capital letters. The capital A's mean they're compulsory. The lowercase a means that they are optional. So don't make that mistake there. Then this example at the bottom left-hand corner, the greater than sign means that the following alphabetic characters must be uppercase. So there's then a compulsory alphabetic character. Then the exclamation mark turns that off. Then the following characters can then be 3 compulsory uppercase or lowercase alphabetic characters. And then the capital N's means any alphanumeric character which is compulsory, means it can be alphabetic or a digit. So that is what that input mask does. First capital letter, then 3 compulsory alphabetic characters, followed by 3 compulsory either alphabetic characters or digits. Then the last example, right, the backslash 0 means that the backslash escapes special characters. 0 is a special character, it has special meaning. So by escaping it like that, you're turning that meta character into a literal. So what this input mask means is that there is a compulsory 0 at the beginning there. The observant people here would have noticed that there's an odd bracket there, which I've just noticed. So just pretend one of the opening brackets isn't there. Okay, so it's a compulsory 0. Then the 2 capital D's means that a number larger than 0 is required. So what this first part of the input mask means is a compulsory 0 followed by 2 compulsory non-zero digits. Then there's a literal hyphen, and the 9 then is a number or a digit between 0 and 9 required. So there's nothing in here that's optional. Everything there is required. But using that backslash 0 is a way of forcing 0 at the beginning of that input mask. So input masks are not at all difficult. It's just a matter of remembering the difference between uppercase and lowercase meta characters, basically. But as I keep saying, the best thing to do is practice and write some code and try it and see what it accepts and what it doesn't. Okay, before we move on, any questions on input masks? But it is fairly straightforward. Okay, the question about these input masks, I don't know the exact answer to your question, but I think you'll find in general they are very similar. I know for the regular expressions, they are definitely the same for QT and all other applications. The input masks, I'm not sure how general or specific they are. They might be fairly specific to QT, although I think you'll find a lot of similarity with other applications. But regular expressions are definitely the same. That's a standard. So that's a sort of answer to your question. Sorry, I just wanted to see, there's another question I haven't read yet. What happens when you try to end it doesn't follow input? Okay, question from Jack. Well, the sort of answer to that is write some code and try it yourself. But no, it shouldn't, your input should not accept or allow a user to enter an invalid character. If they do try and type it, you should find nothing happens. The cursor just stays in the same place. But as I say, the best way to answer your question is to write some code and do that the examples from the prescribed book, and you will see firsthand what happens if a user tries to enter something invalid. Okay, next part. Okay, then looking at validators. Okay, this part is specific to QT. Right, a validator is an object that's attached to input widgets to check the user input. There's a class QValidator, which is abstract. There are some concrete subclasses available. QIntegerValidator, for example, which validates integer numeric input. You can also set ranges on it. There's a QDoubleValidator, which validates double numeric input. You can also set ranges with it. And then QRegular expression validator or Regex validator and QRegular expression validator that validates regular expressions. Okay, I'm just going to jump ahead here slightly. Those of you still using Qt5, Qt5 has the class QRegex and the shortened version like that, whereas Qt5 also allows the full QRegular expression, and Qt6 only accepts QRegular expression. So even though you're using Qt5 and it accepts QRegex, please use the full class QRegular expression so we don't have any compatibility problems. QRegular expression, the full long word, is acceptable in both Qt5 and Qt6, so rather use that. The shortened version QRegex only works in Qt5, so rather stay away from that, please. Okay, then looking at QValidator, the validate method is pure virtual, so if you subclass QValidator, you have to implement this validate method. We'll look at an example shortly. QValidator, it returns enums, and the allowable ones are invalid, intermediate, and acceptable. And the validator will not allow data entry that returns invalid. So Jack, going back to your question, QValidator, if you try and enter invalid input, it just won't accept it. The cursor will just stay in the same place and not accept anything if it's not valid. So you can use QValidator, subclass it. If for some reason you can't use regular expressions or the preset widgets are not sufficient. Quite honestly, you shouldn't really very often need to subclass QValidator, although I have done an example in exercise 6. There's very little that you can't do with regular expressions. So having to subclass Q validator is probably fairly unusual. I, in fact, sort of contrived to use for it in the exercise by using a Q string list for the address instead of separate inputs, so that you had to validate a Q string list. And you can't do that directly with a regular expression, so we had to subclass Q validator. But as I say, in most cases, you'll just be able to use regular expressions for validation or the preset QT classes. So it would be fairly unusual cases where you actually do need to go as far as subclassing Q validator, but you do need to know about it and have some insight into how it works and how it returns these enums of invalid, intermediate, and acceptable. There is an example in your prescribed book that does subclass this Q validator. Have a look at it. It's example 14.3, 14.4, and I think it goes on to 14.5 as well. They're all the same example that follow on, but have a look at that and just make sure you understand it. You do need to know about it. It does give you quite a good insight into how the validation process actually works. Okay, carry on with validators. Right, a validator is an object that is attached to your input widgets to check your user input. And notice a Q validator. Sorry, I'm going the wrong way. Sorry, going the wrong way. I thought I'd recognize it. Okay, subclassing Q validator. Q validator returns enums, invalid, intermediate, and acceptable. For it to be invalid, it means that it is definitely invalid. In other words, there's no chance of fixing it or making it somehow valid. Once it's invalid, it's definitely invalid. It can't be fixed. If it's intermediate, means it's not valid yet, it doesn't comply with the requirements, but it still can become valid. So it is still possible to fix it by adding on something more. So that is what intermediate is. It's something that's not yet valid, but it is possible for it to become valid. And then something that is acceptable means it is definitely valid. It complies with the requirements, generally a regular expression. And then to look at an example, to say we had a Q line edit that we wanted to be able to accept integers between 10 to 100. If a user entered 209 or ABC, those are definitely invalid. There's no way that they can actually become valid. Then a blank space would be intermediate because it is still possible to add digits on there to make it acceptable. Or 5 would be intermediate. For example, adding a 1 or 2 or 3 onto a 5 would make it acceptable because it's within the range of 10 to 100. So an input of 5 is intermediate. It's not yet valid because it doesn't fall within the required range, but it is capable of becoming valid by adding another digit onto it. So something like 5, where you have a requirement for 10 to 100, is intermediate. And then inputs like 12 and 59 are acceptable because they are within the allowable range. So that's just an indication of what the differences between invalid, intermediate, and acceptable are. Okay, in this example code, I'm not going to go through it in detail. It's actually in your prescribed book. It's example 14.9 onwards. It's right at the end of the chapter. Okay, this code at the top here, it's an example about a palindrome. We don't actually need to know anything about that. The part we need to look at here is where it returns acceptable and returns intermediate. So it does some processing of the input, it then checks if it's valid, in this case a palindrome. If it is valid, it returns acceptable. Otherwise, it returns intermediate. Basically, it's saying it's not a palindrome yet, but it probably can become one. In a fuller example, you would also have an option that returns invalid. But have a look at this example. As I say, you don't need to know anything about this part calculating palindromes. It's really just how the validator returns the values of acceptable, intermediate, and so on. So just get some insight into how it works. It's worthwhile looking at the example, but to repeat myself, you don't need to know about the palindrome part. You must just see how the validation process works and how it returns the results. Okay, moving on to regular expressions. Okay, at last, we're now getting to the main part of what you need to know. Okay, regular expressions, which are known generally as regex for short, are a powerful tool for handling strings using a sequence of characters that specify a search pattern. They can be used for validation, i.e. to test whether a string or substring meets some criteria. Can also be used for searching. They provide much more powerful pattern matching than substring matching. They can be used for search and replace. You can replace all occurrences of a substring with a different substring using a regular expression. And then also string splitting. Your regular expressions can be used to identify where a string should be split. Okay, that's just a general indication of what regular expressions can be used for. We will, in fact, only be looking at the first one, so you only need to know how to use regular expressions for validation, testing whether a string or substring meets some criteria. You don't need to know the other three. Those are just for background information. So we'll only be looking at regular expressions for validation. Okay, what do regular expressions consist of? Consist of meta characters. In other words, those are characters that have some special meaning, and some examples, and we'll be looking at them in more detail on the next page, is the curly brackets, the square brackets, the caret, the dollar sign, the full stop, that vertical line, I always forget what it's called, the asterisk, a plus sign, a question mark, and a backslash. And then just to confuse things a bit, there are characters that become meta characters when they are escaped. So by themselves, things like a lowercase d, a lowercase s, a lowercase w, capital D, capital S, capital W, capital N are just literal characters that have no special meaning. But if you escape them, in other words, put a backslash in front of them, they then become meta characters and they have special meaning. So backslash D has a specific meaning when used in a regular expression. A backslash capital X has a special meaning when used in a regular expression. So just remember that these characters by themselves don't mean anything specific. They're just literal characters. But when combined with a backslash, they become a meta character which has special meaning. And then the literal is any character that's not a meta character. So that is your three components of your regular expressions. Your meta characters, which have special meaning, characters that are actually normal characters or normal literals, but they can become meta characters when escaped or combined with a backslash. And then everything else is basically just a literal character that has no special meaning. Then some of the basic concepts of using regular expressions. And OR is that vertical line. Anybody? There, Morna has given us the answer. Yes, a pipe. Okay, I remember now. Right, that's called a pipe. It means OR. So if you use this, the two different spellings of gray with the pipe between them, in your regular expression, it means OR. You can either use GRAY or GREY. So that pipe or vertical line has a special meaning. Then a wildcard, I hope you can see there's a full stop there. That matches any character. So a full stop is a wildcard. It can be absolutely anything. So that's one to watch out for because they're not always very clearly visible. But just look out for full stops in a regular expression that will match any character. Then you have a group in parenthesis. Anything in parenthesis becomes a group. And one of the things you can do with a group is apply what's known as a quantifier to it. So if you have this example here where you have 0 or 1 with a question mark and question marks means 0 or 1 occurrences of whatever's within the group. So you can group items together and then apply a quantifier to them by putting a parenthesis around them. Then you have character sets, and we'll look at these in more detail. But a backslash, lowercase s, uppercase s, lowercase d, uppercase d, lowercase w, uppercase w, define sets of characters. And so we'll look at what those are over the page. And then you have your quantifiers, and you need to know and understand these quantifiers very well. Because if you don't understand them, you're going to have trouble implementing your regular expressions. A question mark means 0 or 1. The asterisk means any number, 0 or any number. A plus sign means 1 or any number. In other words, not 0, anything more than 0. So the difference between the asterisk and the plus sign is the asterisk includes 0, where plus sign starts from 1. You can also define it as 1 or more. The asterisk you can define as 0 or any number. Then the curly brackets, that's not with a literal n, it's with a digit in there. That means a repetition of whatever that number is. So if n is 3, it would mean 3 repetitions. Then you can define ranges. I'm going to jump to the end, where your first digit is the minimum number, and they're inclusive with a comma between them. And the second digit is then the maximum number. However, if you leave out the second number and you put it basically your start digit with a comma, it's open-ended. So that gives you a minimum with no top limit. Whereas the sort of opposite of that, if you leave the first digit blank, put a question mark with a maximum number, that then sets a top limit with no bottom limit. I would suggest you stay away from those two because they can be quite confusing. Rather use the full implementation with the minimum value, comma, and the maximum value. As I emphasize, these letters n and min and max are not the way you use them. You actually put actual digits in there to use the quantifiers. And you also get what are known as character sets. Anything included in square brackets is a character set. And you need to understand this clearly. Your regular expression will match one character within that character set. That does not mean A, E, I, O, U literally. It means one of either A, either E, or I, or O, or U, but only one of them. And then you can put a quantifier after that to make a number of repetitions. Say if we put a quantifier of 3 after that, it would match AAA, it would match AI, U, for example, and so on. But anything within square brackets by itself is just a single character. It's not all of those together. So please understand that the square brackets matches only one of whatever is within the square brackets. Okay, any questions while I gather my breath briefly? Okay, so far so good. Okay, just to digress for a moment, I forgot to mention this earlier. Seeing we've been having problems with accessing recordings, we've come back to MS Teams. I hope you notice that we've set up a team for COS3711, which should resolve the accessibility problems. But if you want to do your own recordings, Windows 10 has that built in. For those of you who don't know, all you have to do is hold down the Windows key and G, and you'll see an application will pop up. All you have to do is click on Start Recording, and then don't forget to stop recording at the end. But you can very easily make your own recordings if you're using Windows 10. Okay, morning, Morne, what's all your questions? Yes, you can use absolutely any reference you like. As I say, for regular expressions, you'll find pretty much everything is the same as what we're saying here. It's pretty much an industry standard. So all these meta characters in that are standard, and you should be able to look at pretty much any source for that. Okay, then we're going to look at pretty much the same things again. So there's a bit of repetition here, but we'll just go through it in more detail and hopefully make it more clear. Right, the asterisk is 0 or any number, so it's pretty much anything. Plus sign is 1 or any number. Alternatively, it means at least 1 or more. Question mark, 0 or 1. Your curly brackets is a quantifier with limits. You can set a range using the different ways that I explained previously. So rather use, if you're going to use these curly brackets, you either use it with a single digit to make a specific number or put the full range. Try and avoid using these open-ended ones because they can get confusing. And just looking at an example, if we have a square brackets with a quantifier 3, that will match anything like AAA or CBB or ACA, etc. It's one digit from within any one of the digits within the square brackets at a time, and then repeated 3 times. So it can, the first time it can be any of the 3 digits. The second time it can also be any of the 3 digits. The third time it can also be any of the 3 digits. So you can get any combination of what's in the square brackets done 3 times. But remember, it's 1 at a time, repeated 3 times. Okay, then the range 1, 3 means either 1 or 2 or 3 characters to match. So you could match A or CC or CBA or CA, anything. The other thing, the order inside the square brackets doesn't matter at all. It makes no difference. There's no significance to the order within the square brackets. In the third example, basically means a minimum of 3 characters up to any number. If that's what you really want, then use that. But as I say, try and avoid this, these open-ended ones. Rather go for ones where you use a specific range. But in this example, 3 comma with nothing means 3 or more repeats of what's in the square bracket in any order. Okay, then looking at these character sets, the lowercase s with the backslash matches any white space character. And so just to make something clear, this example, I've put spaces between the characters here just to make it easier to read. Don't put the spaces there, otherwise they'll be included in your regular expression. That's just done to make it more legible. So the backslash s will match a space, a tab, a carriage return, a line feed, or a form feed. I'm not sure when you'd really want to use those, but it is available. Then the backslash capital S matches any non-white space character. So that's anything else except these characters that were mentioned previously. So in a sense, the lowercase s and the capital S are inverses. They match what the one excludes, the other one includes. The backslash D matches any digit, 0 to 9. Then the backslash capital D matches any non-digit. So it's anything that's not a digit. The backslash lower W matches any what's known as a word character. This one you need to check on quite carefully. Any word character, it's a capital A to Z, a lowercase a to Z, the digit 0 to 9, and then for some reason it includes an underscore as well. So what's referred to as being a word character, lowercase w, is any upper or lowercase alphabetic character, digits 0 to 9, plus the underscore. Then the capital W matches any non-word character, and that's things like your punctuation marks, your special characters, and the white space characters. Then just a word of advice to you. As you all are aware, the exam is open book. I'd suggest you make the effort before the exams to draw up a nice crib sheet for regular expressions with all these meta characters and quantifiers and that. So you've got something to refer to the exam. But please don't neglect your study and understanding of regular expressions. You must know actually how to learn that, how to use them. Trust me, the exam is not the time to try and figure out how to use a regular expression. Crib sheets and having lists of all these meta characters available is actually only useful to you if you know how to use them. So please, I do suggest you prepare and make a nice neat list that you can refer to, but also make sure that you know and understand how to use the items, and don't rely on the fact that the exam is open book and that you can just look at something and somehow magically expect to understand how to use it. Make sure you know how to implement regular expressions beforehand, but make yourself a nice neat list available to have at hand for the open book aspect of your exam. Okay, Mona, I can't quite see what you have posted there. Mona, do you want to tell us what that is you've posted? Okay, well, anyone who's interested there, Mona has posted a readily available cheat sheet, so please have a look at that. It should be quite helpful to you. Okay, then carrying on with the meta characters, character sets in particular. Okay, the square bracket is a character class or set, and it matches only one of what is within those square brackets. The order does not matter. So as I said previously, if you put, sorry, my mouse is a bit sensitive. A-E-I-O-U within square brackets, it matches either an A or an E or an I or an O or a U, only one at a time. And the order doesn't matter. So it makes no difference which order you put anything within the square brackets, but there's a match to only one of those characters at any point in time. And remember, you can put a numerical quantifier after it to match that set repeatedly, but remember, it only matches any one character at a time. Okay, the use of a hyphen can be used to specify a range, and you can put multiple ranges within your square brackets. So this example, you've got a range of 0 to 9 and A to Z capital letters. Again, to repeat myself, because this is a mistake students make often, that will match any one character from that set at a time. It does not match the whole range at a time or A to Z at a time. It matches one character at a time. Then one that causes a lot of confusion, this character, it's used in two different contexts. The character after the open bracket is basically a negative. It negates the class. It matches any character that is not in the class. So if we take our previous example and we put a caret at the beginning within the square brackets, it will match anything except A-E-I-O-U. So it's a negative. It's saying not A-E-I-O-U. So that is if the caret is used within the square brackets. I'm going to get to another example over the page, but it has a completely different meaning if that caret is outside the brackets. But we'll get to that. So please be careful with this. It's something that catches one out quite often with regular expressions. The character within brackets is exclusion. It means not. Outside the brackets, it means something completely different. Then moving on to groups, your parenthesis denotes a group, and you can apply quantifiers to a group. And notice the difference here. We've put cat within parentheses. That means that cat is a group. If we apply a multiplier of 3 to it, we're applying that 3 to the entire group. So this example would match cat, cat, cat. Because we've grouped cat, we've said that's one entity within the parentheses. It's one thing. We're applying a multiplier to that 3 times. If we did a similar thing, but without the parenthesis, we're now applying that multiplier only to the letter T. So the second example would match CATTT because we're saying it's a repetition of 3 on the literal character T. So please note that difference. If you include something in parenthesis, it becomes a group and you act on that whole group at a time. Whereas if there's no parenthesis, your multiplier only acts on the character that's immediately in front of it. Okay, I see somebody's got their hand up. Yes, ask your question, please.
Sir? Hi, sir.
Hi.
I cannot see the chats and I don't know why I can't see the chats while you are.
That's because she's logged in with a guest account or not her Unisa account. We also have the issue, but not too phased about it.
Don't you have the option of clicking on those 3 dots in the menu to select chat?
No, it's a subscription permission they turned off last time I was there. But if you sign in with a guest account or another Microsoft account and not your Unisa account, you can't see the chat.
Okay, well there I think a lot of us have learned something. Please in future sign in before you log into the meeting. That also does away with all the waiting in the lobby messages. Yeah, I just wanted to say something. We have now set up specifically a COS3711 2022 team. So you should get easy access to it when you access Teams. And as just been pointed out, please log into your Microsoft account or your Unisa account before accessing the meeting. Then you won't have these problems. I presume you'd also have to log in beforehand. Well, obviously, you'll have to log in to access the recordings as well. Okay, moving on. Where was I? Okay. Then this one is actually quite important, and it's actually one of the most difficult concepts to understand. What's known as a back reference. Putting a backslash in front of the digits 1 to 9 creates what is known as a back reference, and that it basically matches the same text from a group. This is a bit difficult to understand. I hope I can do it. If we look at this example, where we've got a set here of ABC, so that's either the character A or the character B or the character C. That is, if you like, the first group or entity in our regular expression. Then the second one is the backslash D, or the multiplier of 5. The third entity is our square brackets with a range of A to F of capital letters. We've then got a backslash 2. That backslash 2 is the back reference. It's saying repeat whatever the second entity in our regular expression is. And the second entity is the backslash D with the multiplier of 5. So putting that back reference of 2 there would repeat 5 digits at the end of your regular expression. So it's just a shorthand way of repeating parts of your regular expression, but it's something that can be quite confusing and difficult to understand. So please do a bit of research and look up on it. It also does something quite interesting. It allows you to have recursive regular expressions. For those of you who want to experiment a bit, it's actually a very powerful aspect of regular expressions, these back references, but it's not necessarily something that's very easy to grasp. You need to, say, practice it a bit, and I suggest you do a bit of Googling and refer to these. There's quite a few sites out there which have a lot of information about regular expressions, but please, this back reference, I can't really explain it in more detail than what I've just done, but it repeats a portion of your regular expression, and that whatever number you use is the number or the position within your regular expression. So if you did a backslash 1 in there, it would repeat ABC in square brackets. If the number is 2, as we have here, it repeats the backslash D with a repetition of 5. If we had a backslash 3 there, it would repeat the A to F in square brackets. So using a backslash with the digits 1 to 9, it's known as a back reference, and it basically repeats that same text wherever you use it in your regular expression. So it's actually something that's very powerful, and there are uses for it, but it can be a bit difficult to grasp. And why I'm emphasizing a bit, this was actually asked last year. I can't remember now if it was in the exam or in one of the assignments, but it is something you need to know about. So please do a bit of further reading or looking up on back references in regular expressions. As I said, it's something that is quite powerful and you need to know about it. Okay, then the other meta characters, I hope you can see the full stop there. That's the wild card. That matches absolutely anything. And remember, it's just one instance of it. It's not any number of characters, it's one single character, but it can be any character. Then using the pipe, as Morne pointed out to us, is an OR, and this one would match X or Y, or to using to match months, we have January, February, March, would match any one of those. And again, don't leave spaces in here. I've just done that to make it a bit more legible. If you leave spaces there, they will literally become part of your regular expression. So this OR construct, note you have to put it within the parenthesis, and then it allows your regular expression to match any one of the items that are within there. Note it matches one and only one of them. So this kind of construct is really useful, for example, when dealing with things like dates, for example, or months. And then the backslash, as I've said before, it's used for escaping special characters. Oh, sorry, this is a different usage. Okay, scrub what I said, a backslash. It's the escape character, and it's used for escaping special characters in C++ strings. This is a characteristic of C++. If you use a backslash within a string, you've got to escape the backslash itself. So you've got to use double backslashes within a string. So if, as in this example, when your regular expression has been included in a string, you've got to have a double backslash for the D. Your meta character is \d, and because it's enclosed in a string, you've got to escape it. So double \d. Please be very careful about this. This has caught many a student. If you just write the regular expression by itself, you would write that as \d. As soon as it's included in a string, you've got to put a double \d. You've got to escape the escape character as well. That's just the way C++ works. You just got to get used to it and deal with it. But please be very careful about that. It's caught a lot of people out. Whenever, or shall I put it this way, the way you write a regular expression is different if you write it by itself or if you include it into a string. If it's in a string, you've got to have double backslashes everywhere, otherwise it won't work. Okay, so guys, for those of you not familiar with regular expressions, this is really just a matter of working through this and doing some examples and writing some code. Do those examples in the prescribed book, and then I'll list it in tutorial letter 105. There is the updated code available in additional resources. And for things like the back referencing, please have a look at some additional resources that you should find on the internet. Okay, then to get on to this thing that I mentioned earlier, the caret. Remember, if it's included within your square brackets, it effectively acts as a not specifier. It means exclude or do not include anything that's within the square brackets. If the caret is used as the first character in the regular expression, it indicates that the match must, and I emphasize the word must, start at the beginning of the string. In other words, it's an independent word. What you're telling to it is that whatever you match must be a word by itself. It must not be a substring. It must not be contained within another string. So if you put a character at the beginning, it's got to be a freestanding word by itself. It will exclude anything that is a substring or contained within another string. And then to go with that, you've got your $sign. where it's used as the last character in the regular expression, indicates the match must continue to the end of the string. And that, so if you use the caret at the beginning and a dollar sign at the end, it means that you can only match an independent word, nothing that is in any way linked either before or afterwards to any other string or part thereof. So just remember this dollar sign. If it's the last character in a regular expression, it has a special meaning. But that caret and the dollar sign generally go together, and they get used as the first character and the last character of whatever you want to match. Then another one you'll see from time to time, the backslash lowercase b, that's indicating a word boundary. It's got a similar meaning to the caret and the dollar sign. It basically means it's not a substring. You will often find part of a regular expression with a backslash b and then a few characters and then another backslash b. Basically saying that you want a freestanding word must not be a substring. And then the capital letter B is sort of the opposite of that. Basically saying it can be a substring. Whatever I'm searching for can be contained within another string. It can be a substring. So note the difference between the backslash B and the backslash capital B. One is saying it must be an independent string, not a substring. The other one is saying it must be a substring. It can be contained within another string. Right, then some points to note. Generally, when you're dealing with regular expressions, checking is done character by character, digit by digit. And this refers particularly to dealing with dates and numbers. When you're trying to match a date, and I can pretty much assure you, you will be getting a question in the assignment or the exam that requires you to match some kind of a date. You do not match something like 1985 all in one go. You match it character by character. You've got to match the 1, then you've got to match the 9, then you've got to match the 8, and then you've got to match the 5. They're all done independently, character by character. This is an aspect that catches a lot of people. They try and match 1985 all in one. You can't do that. You've got to draw up your regular expression to match it character by character. So please understand this aspect when dealing with regular expressions. You're looking at matching character by character, not generally whole words or sections of strings at the same time. Then I've already mentioned one, the using alternatives or the or with the pipes. Again, please don't put those spaces there. That's just for clarity. Just remember that if you do something like that, it will match one and only one. It will either match January, or it will match February, or March, or April, or May, but only one of them at a time. It won't match more than one of them. Basically, by doing this kind of construct, you're saying that you must match one and only one of whatever is between those parentheses. Then the next thing to note is the multipliers and the wildcard. Make sure you understand the difference between the full stop and the asterisk and a question mark and a plus sign. You will use those quite frequently, and you need to know the difference between them and what they mean. That's quite an important aspect of understanding regular expressions. And then again, these ranges, know how to use them. And as I've said before, try and avoid using the open-ended ones that tend to be a bit confusing. Either go for a full range with a lower and upper value or with a specific number. Only use this if you really, really want an open-ended expression. And then the brackets, please take note of the different types of brackets and when you use parentheses and square brackets and curly brackets. It's also an aspect that can be confusing when you're trying to do regular expressions, particularly if you're trying to do it under pressure in an exam, so don't get them mixed up. Okay, then we'll look at some examples of regular expressions. Okay, if you have a regular expression CAT by itself, that will literally match the string cat, CAT. So that is just a string literal. Then you have a C with an asterisk and AT. That means 0 or any number C followed by AT. So that will match AT, it will match CAT, it will match CCCCCAT. So it'll match pretty much anything as long as it's got AT in the end of it. Then C with a question mark and an AT, that means 0 or 1 incidences of C, so that will match AT or CAT. In other words, 0 C's or 1 C, and that's all it'll match. And C full stop T will match any 3 characters as long as they begin and end with C and T. And the middle character can be absolutely anything. Then the ones with the backslashes, remember your full stop and your asterisk are meta characters. They have special meanings. So by escaping them, you're making them into literal characters. So that regular expression would only match C full stop asterisk T and nothing else. Because you've escaped them, they do not act as meta characters. They become literal characters. So putting a C with a backslash full stop backslash asterisk T will only match C full stop asterisk T and nothing else because they become literals. Then this example with the square brackets, we have a literal C, so there has to be a C at the beginning. Then the plus sign says that there's 1 or more occurrences of whatever is within the square brackets. So it can, as an example here, be C followed by C, followed by 3, 2, followed by B. All of those come from within there, and there can be 1 or more instances of them. And then the last character is a literal Z. So this regular expression is saying there's got to be a C at the beginning and a Z at the end, and 1 or more of the characters, any number, as long as there's at least 1 of the characters within the square brackets. Then this regular expression, the cat with the pipe dog sat on the mat, will match either the cat sat on the mat or it will match the dog sat on the mat and nothing else. It will only match those 2 options. Remember, it's got to be that complete word, cat, or the complete word, dog. So there's only 2 things that will match. The cat sat on the mat or the dog sat on the mat. Then your backslash W with a plus sign is your word characters, and it's the same as saying A to Z lowercase, A to Z uppercase, 0 to 9 digits, plus the underscore, don't forget the underscore, and then repeated 1 or more times. Then the backslash D with a 5 means there must be exactly 5 digits, and that can be any 5 digits. But it must be repeated 5 times. It can't be repeated 4 times or 6 times. It's 5 and only 5. And then the caret or the cat, it will match the word cat, but only if it occurs at the beginning of the string. Remember, by putting the caret at the beginning, we've said it must start at the beginning of the string. It cannot be a substring. So that will match cat only as long as cat is at the beginning. It can't be a substring. However, if we change it now and use the caret within square brackets, what we're now saying is we can match anything except a capital C or a lowercase a or a lowercase t, anywhere within your regular expression. So please make sure you understand the distinction between the 2 different usages of the caret. They can be quite confusing, and the way you use them is very, very different. Then the last example, the backslash D, we're saying any digit, 0 to 9, repeated 3 times, then a literal hyphen, then any digits in the range 0 to 9 repeated 4 times. So that basically gives us any 7 digits with a hyphen after the 3 digits. And that will match that regular expression. Just remember that the \d and the 0 to 9 in the square brackets mean exactly the same thing. So you can actually write those either way you prefer. You can use the \d or you can use the 0 to 9 in square brackets if you prefer, but they mean exactly the same thing. It's just the repetition that's different in that example. Okay, then moving on to regular expression validation and how to use them. Okay, this is an example in QT5. As I said before, QT5 uses, or you can still use Regex, but please don't use it because regular expression is available in QT5 and it's all that you can use in QT6. So please don't use this class at all. We'll look at the other one. This is the one you must use, is regular expression, and this is replaced Regex. As I say, this regular expression is available in QT5, and it's also all that's available in QT6. So use this one, and then it won't matter whether you're using QT5 or 6. This is the way you use it. You declare your regular expression object. In this case, we call it RE. We're calling the constructor. And we've put our regular expression as a string, which is what's required. That's why there's the inverted commas. And notice that we've escaped the backslashes for the D's because it's now within a string. So you've got to have double backslashes everywhere. This regular expression matches the 2 digits, the \d, the \d. Then there's a space. Remember, if you leave a space, that will be treated as a literal space. And then the \w, one or more instances of it, is your word characters. So that is how you set up your regular expression. And the way you check it is you use this class called regular expression match, and you call its match method, sorry, excuse me, on your regular expression. And you put the string that you want to test within there. So by calling regular expression match, you are now matching your input string with the regular expression that you defined in your regular expression object. So you've got 2 different things here. You've got your regular expression where you define your actual regular expression, and then you call your regular expression match, and you put in the string that you want to match it against. And then this regular expression match has a method called hasMatch, which returns bool. And you can then check if you actually have a match with your input string and your regular expression. So that is how you use regular expressions. And just to clarify, you don't have to use the name RE, although you will see that commonly used in the examples. You can use any name you like. You don't have to use the name match for your regular expression match. It might actually be confusing because there's a method with the same name. You can use any name you like there, and you don't have to use hasMatch there either. You can use any name you like. But anyway, that briefly is how you use your regular expressions. You set up your regular expression, you test it against a string, and then you test the result to see if it's true or false, basically. And again, just to repeat myself, the best way is write some code and run some examples, and you'll see how it all works. Then the regular expression validator class. Again, you set up a regular expression, same as before. Then you set up your validator. You call the class regular expression validator, and you pass your regular expression to it as an argument. Then you have a Q line edit, which you would probably have declared before. Then all you do is you call the set validator method of Q line edit, and you pass it a pointer to your validator, your Q validator object. And it's as easy as that to set up validation. The next trick, of course, is you've then got to connect your signals and slots to actually do something with it. But this is basically how the validation works. You set up a regular expression. You pass that regular expression to the Q validator class, and then you, then you set the validator on your Q line edit. So it's actually, my mouse is too sensitive. Actually, I'm going to go back to this previous one because okay, this code's basically the same. I'm just showing you the connect statement here. We've connected the return pressed signal of Q line edit, and then we've got a slot in this example is called calculate, and that's where we do something if our regular expression has matched. Remember, this return press signal is only emitted if your Q regular expression or your validator validates the input. If the input in the Q line edit is not valid, this return press signal will not be emitted. That signal is only emitted when the input in the Q line edit is valid. So that is the only time then you can process the input. It won't be processed unless you have valid input, because no signal will be emitted unless the input in the line edit passes the test of your regular expression. But that basically is how you use validation. You set up a regular expression, you declare a validator object, you set that validator on your line edit using the set validator method, and then you connect your signals and slots. There are a couple of other signals you can use, but return pressed is probably the most common one. And as I emphasize, that signal will only be emitted once there is valid input in your line edit. And doing this would prevent your application from doing any processing until such time as the input is valid. So this is something you are going to have to take note of and use in your applications. We don't want any input kludges and invalid input in our applications. Are there any questions so far? No. Okay. We're nearly at the end. And just looking briefly at some of the questions that have been in past papers. These are some examples. This first question, we were given 3 regular expressions, and you had to provide three strings which provided each of those expressions. So the first one, you've got your character, which excludes your lowercase s, in other words, the white space characters, and it's 4 repetitions of that. So what's valid there is any 4 characters excluding white space, right? You said the character in the bracket exclude anything lowercase s. So that's no white space. So it can be any other characters except white space. So that would be an example of the correct answer. Then the second example is you've got 0 to 9, capital A to Z, lowercase a to Z. It's a minimum of 2 and a maximum of 5 repetitions. So any answer that includes 2, 3, 4, or 5 digits or combination of upper or lowercase characters is acceptable. Those are all acceptable examples of output. And then this one is a little bit tricky, and please note the trick that I mentioned earlier. Note the 2 full stops at the beginning. Those are wildcard characters. So those first two characters can be absolutely anything. It's then followed by digit 0 to 9, capital A to F, or lowercase a to F. Notice there's no repetition here. So that is any one, and I emphasize one. Only one of those characters within the square brackets is acceptable. So it's 2 wildcard characters plus one of the characters from within the square brackets. So basically you need an answer with 3 characters in them. The first 2 can be absolutely anything. The last character must be one of the ones allowed from within the square brackets. But please be very careful of that wildcard character and the full stop. It's very easy to overlook it. And then this, from a different past paper, was use a regular expression to check that a document number meets a particular format in the order given below. The first 3 characters had to be GDL, PL, or RGL. Then there had to be a slash, that's a literal slash. And then exactly 3 arbitrary uppercase alphabet characters, another slash, and then the tricky part, a year value in the range from 1900 onwards. And a regular expression that should match that was using the OR operator, the pipe, which would allow one of GDL, PL, or RGL, that fulfills the first one. Then we've got a literal slash. Then we want 3 uppercase alphabetical characters. So we've got a range A to Z with 3 repetitions. Then we've got a literal slash. And then the more complicated part here. And I've actually just got to think carefully about what I've got here. Sorry, I'm just getting my thoughts together. Okay, I'm not sure why that backslash. Oh, okay, sorry. I've got my thoughts together. Okay, it's a literal 1. The backslash then is the escape character. So that makes it a literal 9. It's not the 9 as in digits, 0 to 9. Then we have the pipe for the OR operator. Then we've got digits in the range 2 to 9, followed by digit, and it's 1 repetition, followed by digit in the range 0 to 9, 1 repetition. And then we have the backslash D, which is any digit, and it's 2 repetitions. And that should hopefully match that regular expression if I've done it correctly. But test that for yourselves, see if it does actually match, and fix it if it doesn't by some chance. But this is an indication of the standard and level of questions that you will get in the exam as far as regular expressions are concerned. Just bear in mind that you might not get them standing by themselves like this. You might have to implement them as validators with a little snippet of code. But you've got to be able to handle regular expressions of this kind of standard. I'd suggest you have a look at this last one and check it for yourselves and make sure it's correct and that you understand how to do it like that. But that basically is all we have for regular expressions. Are there any questions about that? All simple and straightforward. Okay, guys, if there's no questions, then we'll be ending there. Those of you who haven't submitted your assignments yet, please get on with it. You've only got a couple of days left. And please, those of you who aren't up to date with your exercises, get up to date. And so they're getting sort of more challenging. There's more to do in the ones that follow, but you will have 2 weeks to do them. Other than that, keep at it and keep writing code. Okay, the brackets, if you you want a literal bracket, you just need to, sorry, I'm answering the question here. If you want a literal bracket, you need to escape it. You put a backslash. Whenever you want to use a meta character as a literal, you must just escape it. It's as easy as that. Okay, Nettie, your question. Can I ask a question?
Yes. Hello.
Okay, carry on.
Can you hear me?
Yeah.
I wanted to ask on this last part on the regular expression for the last paper.
Yeah.
The year value in the range from 1900 onwards. Will
Yes.
1910 fit? Because I wanted to ask on the 2 to 9. Will
Okay.
one come through?
Okay, there's an or sign there. So the first one is 19 or 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So it's either or of those first two. And then that's followed. That's what makes that up. And then it's followed at the end by 2 digits. So if you look at the requirement, 1900 onwards, from the 1
Yes.
and that parenthesis through to the closing parenthesis, all that is dealing with is the first 2 characters, the 19 or the 20 or the 21 up to 20. In fact, it'll go up to 99. And then this backslash D2 is dealing only with the last 2 characters. So this whole complicated part at the front here is only dealing with the first 2 characters.
Also, maybe if I may ask, is the secret behind these 1900 onwards, you have to group these digits, like the first 2, and make an expression for them and the last 2, so that the expression.
No, what you must do, you must listen carefully what I said. What I said is you must do it character by character. You must basically deal with the 1 and then with the 9 and then with the 0 and then with the 0. As it turns out, for the last 2, they can all be anything from 0 to 9. So there we've just said we'll just do that 2 repetitions of it. So we're dealing with the 2 characters there together. But when you look at things like matching these numbers, you must look at it character by character, deal with each character in turn. Don't try and look at it as the whole number at once.
All right. Thank you.
Okay, any other questions? Okay, guys, then we'll end there. Thank you. And please keep coding. You need to write lots of code. If you've got any queries, please post them on my Unisa and I'll answer your queries there. Okay, thank you.